Okay, welcome everybody to today's workshop, which will be on advanced JavaScript, ES6, best practices, and the way of the JS Ninja. This is something that I really wanted to do a long time ago because I felt like some of these topics weren't really gone in depth in the curriculum. And while they're not critical, like just to be for any entry-level position, they will give you a rather big edge during coding interviews and during your first job. So without any further ado, let's get started. A little bit about me. I am Sergey. I'm 25. I live in Guadalajara, Mexico with my wife. I'm currently working as a full-stack engineer at Luxoft. I work at a rather large project, and I'm a bit of a JavaScript and tech fanatic. I love just everything JavaScript. I love tech, gadgets, just reading about blogging for that. I'm actually considered multiple times to start a YouTube channel just for that, for maybe talking about tech or primarily I would like to focus that maybe on a more explained tech like I'm 5, so maybe how to buy a phone if you have no knowledge of smartphones whatsoever, things like that. Yeah, I guess I really enjoy it. I'm kind of passionate about that, and also I'm a bit of a Nintendo lover. I love everything Nintendo. Currently, I love what they did with the Switch, which I'm enjoying quite a lot right now. So, yeah, I think that's enough about me. Let's get started with the first major topic, which is hoisting. So, hoisting is a bit of an interesting topic, and it is somewhat, it's actually pretty well documented, but it's not that often talked about despite being such a critical component of how the JavaScript programming language works. Now, what is hoisting? So, hoisting is basically something that happens to function declarations in JavaScript. All it means is that when you declare a function in JavaScript, this will be hoisted to the top of the enclosing function or global scope at runtime. And this allows you to use the function before you declared it. And here we can see a simple example. We declare function hoisted at the bottom of the file, but we can still call it from the start. And that is because of this hoisting mechanism that the JavaScript engine does when it runs your file. It first scans the entire file and then hoists all the function declarations to the top of it, even if you can't see it. So, before you get all excited, when does hoisting not work? Well, there's two major cases you need to be aware of. Number one, when you declare functions as expressions. So we know how to declare functions with the function name syntax, but if you assign this function to a variable, be it this way, for example, if you const do stuff equals function, or if you do an arrow function, which you assign to a variable, these do not get hoisted. Okay? So, as you can see here, neither of these functions are hoisted because when I try to log them, they both return undefined. So hoisting does not work on function expressions. And also another case of when JavaScript hoisting does not work is when you try to access a function outside of the scope in which it was defined. So here we can see how at the end of the file we write function A, and inside function A, we write function B. What happens is, if you try to log both functions, you will see that console logging A will return A, because A is hoisted to the top of this scope. But because B is defined inside the scope of another function, it's not available in the global scope, so it returns undefined. So basically, hoisting only works on that scope level, okay? Don't get that mixed up. It happened to me. It wasn't fun. I had a heck of a time troubleshooting why that didn't work. Now, what is hoisting good for? You might be wondering, like, why would I want to use functions before I declare them? Here's a funny story. Function declarations are only a set of implementation details instructions. So basically, when you write a function declaration, which is the normal way we are used to doing things, you're basically writing them before the actual action of the function execution, which basically is what provides the context. And this goes against how the human brain works. So here's the story. If I told you the recipe for a dish, would you prefer I explained how to prepare every single component of the dish before I even told you what you were cooking? You probably wouldn't like that, right? So this is how hoisting can help us. It can help us by basically writing components and files which give us the context from the start and offer implementation details last. Now, if this is still a bit fuzzy for you, no worries. Let's see an example. So here we can see what a typical page or component looks like before hoisting. So you write to the file and you're just greeted with a ton of implementation details for every single function that is used by the project. So on login form submit, on sign up form submit, render login page, render sign up page, and function user first time of page, which returns if the user is, this is the first time the user has visited the page. Then we do the event handling for the click events, submit events, whatever. And then if it's the user's first time on the page, then render sign up page. Otherwise, render login page. So that's all fine and dandy, but we had to do quite a bit of reading to even understand what action was actually going on at the end of it. So with a bit of hoisting magic, we can make it look a bit like this. So notice from the start, you're greeted with the actual action that is done on page load. So if user's first time on page, render sign up page. Sound went out. How long ago? That's not good. 15 seconds? 30 seconds? Can somebody elaborate how back I should go? Can you all hear me? Right now? Okay, good. Thank you. Okay, I'll go back about a minute. So I guess let me just go back to before hoisting. So quick recap. Basically, what we were talking about is before hoisting, you have to do a lot of reading to understand what action is actually going on the page. So you have to read all the implementation details just to get some context of what is going on. And that's not very fun, and that's not exactly how our human brain works. Now, after hoisting, what changes basically is that you now get the context from the start. You now see that when the page loads, we check if it's the user's first time on page, and if it does, we render the sign up page, otherwise render the login page. And while this doesn't technically look like it's already defined, because it's defined all the way to the bottom, because these are function declarations, they're hoisted to the top of the file, giving us basically a way to write context before the actual implementation details. Same thing goes, we organize our code a bit tidier, so the functions appear as we are sort of running them. So user first time on page, the rendering, and then the event handling. So overall, I think we can all agree, this is a much more readable file, like it's easily identifiable at a glance. Okay, so that is hoisting. Let's go to the next section, which is ES6. Now, what the heck is ES6? Because ES6 is a term thrown around quite a lot. So ES is simply short for ECMAScript. Now, ECMAScript is a standard, and JavaScript is the most popular implementation of that standard. JavaScript implements ECMAScript and builds on top of it. In fact, every time you see ES followed by a number, it is referencing an edition of ECMAScript. So that's what ES6 means. ES6 is the 6th edition of the ECMAScript standard. So as of today, there are a total of 8 editions. However, ES6, sometimes sadly referred confusingly as ES 2015, since it was released during that year, is the most popular and widely adopted version of them all. And it's what you should be using. So let's just go over a few of the things that ES6 introduced. So, number one, let. So I'm sure all of you are familiar with let. I'm going to make a quick pause. Can everybody still hear me? I guess it's just paranoia at this point, but just making sure. If my sound ever goes out again, please do let me know as soon as possible so I can just stop what I'm doing right there. It's the first time that happened to me, but thank you everybody. Now, going back to let. Let is the new way of declaring variables. So you can see that this is the old way using the ES5 standard. So we previously used bar to declare variables, and now we're using let. So they work nearly exactly the same. Keyword here, nearly. There are some exceptions. So far, it looks like they work the same, right? And we could even prove that by seeing function scoping. So for example, here you can see an easy example of function scoping. So if you define a variable inside a function, it gets scoped to that function. So here we can see that my function defines a and b with var and let. And then when we log both of them, for example, here we run my function, it logs 1 and 2. However, if we try to do console log A and B outside of the function, it returns undefined. So in this sense, both work the same. They're both function scoped. The differences start to appear once you consider something called block scoping, which is something we actually kind of expect to happen on both sides. But this is actually a well-known, well, maybe not bug, but it's, you could say, an unpredictable part of bar. So let me show you what I mean. Here we can see an interesting example of what's called block scoping. So basically, when you define the variables inside of something like an if block, for example, which by block we mean these. This is what we call a block. So when you define these variables inside of an if block, and if you try to log them outside of the block, something very interesting happens. Notice how when I run my function, now it logs 1 and undefined. What gives? So what's happening is that when you define a variable with var, it is still scoped to the function it's in, or the global scope if it's not in a function, while let will always be block or function scoped, depending on what comes first. So this is actually something we prefer almost 100% of the time, because honestly, that it just makes it much more predictable. Like, you would only expect that variable to exist in the scope you defined it in. So in that sense, let is far more secure and far more reliable. While bar, as you can see here, has the unexpected side effect that if you define it inside a block, it won't respect that block scope. It will just use the current function scope, which is not exactly as predictable as we would like. So that is why we always try to use let over var. If you ever get quizzed in an interview, when would you use bar over let? That's a trick question. You would never use bar over let because of this side effect. The only valuable or valid reason I would consider in an interview of a student answering I would use bar over let would be maybe if browser compatibility was a concern. If we were working with very old browsers, like maybe Internet Explorer 6 or 7, or even I think 8, I think those don't support let. So then you would avoid let, but only because it's not supported, not because var is better. Okay? Great. Let's move on to const. So const is an interesting type of variable. So it works just like let in that it is used to define the variables. But the difference between const and let is that const stands for constants. And constants are variables which you can never alter. Okay? So basically, if you define a const a equals 1 and then you try to change the value, you're going to see an error thrown. So the error thrown is going to be type error assignment to a constant variable. So constants are something you should only ever use for variables you do not want changed. Now, I should have included this in the presentation, so pay very close attention to what I'm about to say. Consts have a very interesting behavior on objects, okay? So if you were to define an object with const, so for example, if I were to do const user, and then I defined name, I don't know, Sergey, and then age 25, if I try to reassign the user to another object like so, this would throw an error, okay? So this is exactly what you would probably expecting, that this throws an error. But if I were to do something like this, so I'm just changing one property on the object of the constant object. This does not throw an error. This is kind of weird. Like, I just told you that constants cannot be altered, but this is kind of telling you otherwise. So basically, the only thing that constants forbid is reassigning the variable of the original reference. But if you assign a constant to an object and then you change a property on that object, constants will do nothing to stop you, okay? So this is, in a way, why many people consider JavaScript's constant implementation to be flawed, because a proper constant should never be able to be modified, no matter what part of it you're trying to edit. So be careful about when using constants on objects, because this is a sad side effect of constants, that they don't protect the properties that live on those objects. All right, let's move on. Now, template strings are another very interesting part of the ES6 standard, and they basically improve the way we write strings. So say we wanted to write a composite string, basically a string built of maybe a variable or multiple strings. So say we wanted to write a greeting saying hello and then the name variable that you inputted. So you can see here name is Sergey, and I just want to write hello plus then the variable plus whatever. So this is the way we did it in the old ways. It was doing string concatenation, and it is not fun at all to write, especially when you're doing tons of this. This gets super tedious to write very fast, and it's not something I particularly enjoy doing anymore. Thankfully, since the dawn of ES6, we can now do what's called template strings. To write a template string, it's very important that you should always use what we call the backticks. Backticks are what's used in ES6 to tell the JavaScript engine this is a template string. So no doubles, no double quotations, no single quotations. It has to be the backtick. So to write a string template, you write a backtick, and then to inject a variable, it's as simple as doing $, and then the syntax for the squiggly braces. Now, please don't confuse this with jQuery. I know I did confuse this, so it's kind of dumb me telling you to not confuse it, but I'm going to still try anyway. Don't confuse it with jQuery. Just because it's the same $ jQuery uses doesn't mean this is jQuery functionality. This is native ES6 functionality. And basically you use $ and the squiggly braces to basically escape any variable name, and it injects it as you expect. Both of these will log hello Sergey and exclamation mark. Same result, just different ways of doing it. All right, cool. Let's move on. Now, arrow functions. Arrow functions are a fantastic arrival on ES6. Something I love doing, and something I also see quite a lot of students have problems with, and I don't blame you. So basically, arrow functions are just a leaner way of writing functions, but they do come with some pitfalls. So I'm just going to try to cover the most basic ones of them all. But just know there's a lot more to arrow functions that meets the eye. So here we can see the old way of writing functions, like function and then the name of it. But when we start shifting to arrow functions, something very interesting happens. So basically, you cannot write an arrow function with a name. If you want that arrow function to be named, you have to assign it to a variable, like so. So in this sense, sadly, arrow functions do not benefit from hoisting. And that's okay, because that's not what you should be using them for. So we will soon see why you would use an arrow function. But basically, this is just the same syntax change. And you know what? I should have added a parenthesis here. Just kind of a typo on me, so my bad. So there we go. Here's a typo fix. So basically, the difference is you don't write function, as you can see here. And also, you have to add this arrow, which is what gives these the name of arrow functions. So if you're like me, you probably saw this and said to yourself, that looks bad. That looks harder to understand for me. I have no idea why anybody would use them. And I don't blame you. That was my first thoughts as well when I first learned about them. And I did not want to use them. So let me show you why you would want to use them. Arrow functions have actually a very interesting trick that basically allows them to be, how can I put this, morphed. And what do I mean by morphed? So let me show you what I mean. I think I just noticed I have an extra slide here. So let me delete slide 16. This was supposed to be the original first slide on our functions, but whatever, I think it still makes sense. It's the same example we saw previously, but the only difference is we defined function as a variable, as you can see here, ES5 greeter and ES6 greeter. Now, let's go back to the morphing time, right? It's morphing time. So how can arrow functions be more useful? And funny you asked that. So here you can see a very interesting function called times2. All it does is it receives a number and it returns that number times 2. Now, this is a perfect scenario for morphing time. What do I mean by that? So because we only have one argument, arrow functions allow us to delete the parentheses. As you can see, there's no parentheses, and that still works. And this makes these look quite a bit cleaner, but we can go further. Just do keep in mind, this only works when you only have one function argument. If you have two of them, you have to include the parentheses. And then we can go further by basically, you can delete these squiggly braces, the function body, and write entire function content in line. This might look crazy at first, but bear with me. This basically what's happening here is when you have only one line of code and you're returning that line of code, you can actually delete the body and delete the word returns. The reason why arrow functions have an implicit returns hidden right here, like it's inserted at JavaScript runtime. So even if you can't see it, this arrow function is read. This function receives a number argument and it returns the number argument times 2. So there's an implicit returns here. So as you can see, it's way, way cleaner than what we had originally. And this is what you would be using arrow functions for. When you have maybe one or more arguments and you're returning one line of code, that's the perfect scenario of using an arrow function because it just looks so much cleaner. Don't believe me? Let me show you. You can see here a very interesting way of doing array manipulation. So here we have a simple array of numbers. So numbers 1 to 5. And we're going to create 2 arrays called doubles. So I know this will crash, by the way, because these 2 are constants. I should have named them differently. So whatever. Here you can see that I'm using the map function. The way, for those unaware, map is a function you can call on an array. And basically it receives one function and whatever gets returned at that function gets inserted into a new array. So basically this is the old way we use map using the ES6 function. So it receives the function, it receives the number and returns, actually another typo here, number times 2. So you can see that this would basically return an array of doubles. So we return 2, 4, 6, 8, and 10. Now this looks okay, it looks alright, don't get me wrong. But we can go further. If we remove this function and convert it to an arrow function, it would end up looking a bit like this. So basically, here we have doubles, and then we do numbers.map. It receives a number and returns the number times 2. See how much cleaner that looks? This is what you would this is what you would be using arrow functions for, to make your code look cleaner and as such easier to understand and easier to identify at a grasp. And that is a hint of what's coming, by the way, very soon in the session. So yeah, arrow functions, if you're scared of them, I don't blame you. I was scared of them too, but do try to get comfortable with them as soon as possible because they are such an amazing way of writing JavaScript. Honestly, I just can't go back to the old way of writing JavaScript. They're just so helpful in some situations like this. They just make the code look so much cleaner. So yeah, and then we have something called destructuring, which I have seen actually gives quite a few students quite a bit of trouble. And I don't believe you. It wasn't the cleanest syntax for me either, if I'm honest with you guys. So basically, destructuring is this very interesting way of extracting variables from an object to make it easier for you to type them out. And what do I mean by this? So here you can see that I have a data object like so, which I erroneously defined it with var. Sadly, shouldn't have done that, but whatever. So here you can see I defined a data object, which has the properties name, age, and address. An address has the properties street, city, and zip code. The thing about this is if I wanted to access the address street, I would have to do data.address.street. And that's okay, but we can go cleaner by using destructuring. So the way destructuring works is you do const, then you use this destructuring syntax, the squiggly brace syntax. So by using this syntax, all you're telling it is, hey, I want to extract the variable name and age from the data property. And that allows me to just do console.log name and console.log age, and it will output Sergey and 25 with no problem, instead of having to do console.log data.name or data.age. It's very helpful. And here you can see an even more helpful example of being able to access street, city, and zip code without having to do data.address.street, data.address.city, and data.address.zip code. See how that's very verbose? So by using destructuring smartly, we can just easily extract everything to a variable that we can now just do console.log using the template strings we already learned about, the name, age, lives in, street, city, and zip code. And this would output something like this. Sergey, 25, lives in JS Street, Chromeville, 12345. So pretty cool stuff if you ask me. It makes for much cleaner code and overall a much more fun experience while coding, if you ask me. And now, that is structuring to extract properties. However, you can also do the inverse of this to basically build objects. So here you can see a basic example. So we have 2 properties, name and age. And then we're building a person object the old way, using ES5. So ES5 objects, you have to do name, and then basically the property name, 2 dots, and then the property value. Property name, 2 dots, property value. And notice how here we're basically naming it exactly as the variable names. So wouldn't it be fun if we could just like write it once? And yeah, we can. Thanks to ES6 Destructuring. All you have to do is just use the same syntax, but you only have to type the variable name once. And all this is doing is this will be transformed at runtime into this. The downside is pay attention to this, since this only works if you want the variable names as the object property names. So say you wanted this ES6 person to be named maybe first name and to assign name to it, you can't do it this way. You would have to go back to the old way. Okay, so it's still an nifty feature just to save yourself a couple of keystrokes. And finally, we have modules. Now, modules, I want to give you a big warning. This is, as of today, not 100% supported. So this won't work on most browsers. I think it's already supported by Chrome, but that's still not a very good reason to use it. Reason being, a lot of people don't use Chrome, and you're just going to have your code break on so many other machines and cell phones. So don't use this yet, but just do know that this syntax is coming very soon to be supported on all browsers, and it's actually used widely by React, which you will be learning about very soon, or probably already learned about. So basically, it's kind of similar to the syntax that Node.js uses for their modules, and the way it works is you write functions that you want to be used on some other file. So here you can see in my sum.js module file, I write sum as a function, then do export, and using the ES6 object destructuring, I export an object with the property sum on it, assigned to the function sum. And basically then that allows me to, inside my main app.js, I can do this cool syntax called import. Then I use, again, object destructuring to, because I'm some.js, as you can see, I exported an object. Then I'm going to, from that object that I imported, I'm going to extract back the sum. And then I just type from, and then the file that's from. And that allows me to just in my app.js do console.log sum 1,2. That's pretty cool. And it makes for much more modular code. Sadly, this is something that you can probably only do if you're doing React applications, but you will benefit from this very soon enough. Now, I think that's about everything we have as far as ES6 goes, but please hang on, because we have the best part of the session, if you ask me, which are anti-patterns. So I already covered that we were going to go into best practices on how to build applications. But if you ask me, the best way of learning best practices is by learning about anti-patterns. What are anti-patterns? So anti-patterns are basically certain patterns in software development that are considered bad programming practices, and as such, you should actively avoid them. There are so many anti-patterns and bad practices that we not even an entire 5-hour session could probably go into all of them. So we're just going to cover all the biggest ones, which I think you should be most familiar with from the get-go. So programming pattern anti-pattern number 1 is poor naming conventions. This is something that I've seen across almost every single student's project, and probably amongst every single of my first projects when I first learning. So this is not something you learn from the beginning, and I don't blame you. So don't feel bad if you made this mistake like me, because I made this mistake as well. But basically all I'm saying here is name variables and functions accordingly so that it's easy to basically for any developer to understand what you mean on that example, okay? So be careful when you're naming variables. So this is a common problem. So you can see that this here we're naming x to the variable 1. What the heck does x even mean? So here we're assigning JS form to the variable f. You might know what f means. I know what f means. But if somebody else visits my code and sees the f variable, they'll have no idea where that comes from. And that's poor naming convention. The solution here would be to rename everything to be more descriptive. Even this function called dashboard. What the heck does dashboard do? Show dashboard, hide dashboard, view dashboard, render dashboard, get dashboard. Like there's no good naming convention here. The solution would look something like this. So here you're storing everything into a clearly well-explained variable like num for number. Here I like to use the dollar prefix for any jQuery object. It just makes it easy for me to, hey, that's a jQuery object. It makes it easy for me to know that's jQuery related stuff. So I use jQuery and then a good explainable name, JS form element, then user, data change to user, and then my dashboard function changed to render dashboard. So it's a lot more direct. It's to the point. It's clear what that does. And that's poor naming convention solution. Now, next anti-pattern. Mutating state. Now, this is a hard one, if I'm honest with you. It took me quite a long time to just get used to not mutate state. And basically what I'm saying by this is, when you write a function, I'm sure you probably all do this because nobody told you otherwise. It's common that you want to alter variables outside of that function. So here, for example, you can see that I have a function called verify answer, and inside of that, I'm incrementing the value of score by 1. However, this is what we call mutating state, because inside of a function, you're altering the basically variables outside of it. And while you might think there's nothing wrong with that, this is what leads to having one of the most hard to debug applications. So, oh, good catch, Daniar. Yes, you're absolutely right. That shouldn't be a const. Great catch. So I was kind of tired of writing this, so excuse the occasional mistakes. So, yeah, basically, here, going back to our explanation, we're altering the variables outside of it, and this is what we call mutating state. How would we refactor this so it doesn't mutate state? It would be actually something like this. So here we have our verify answer function. It goes a bit like the previous one that checks the user response, but if it's correct, it just returns true or false. And then outside of it, we're doing if verify answer, then score equals score plus 1. What does this achieve, you might think? What's the point of that? It's more code. And the reasoning is simple. By making your functions not mutate state, it makes them, number one, easier to understand. Like, for example, if I told you, hey, I have a function called verify answer, would you have been able to deduce on your own that this increased the score by 1? Probably not, right? That's not very intuitive. Verify answer doesn't tell you just the name that increases the score by 1. So not mutating state helps keep the functions linear, smaller, more objective, and maintainable. And not only that, it also makes it keep it a bit more clear when you're altering state. Now, huge caveat I want to mention. You will have to mutate state at some point. So don't feel like you might probably already be wondering, so where will I mutate state if I can't mutate it everywhere? You can mutate state inside of some functions. What I'm just saying here is try to do it as little as possible, okay? Because most of the projects I've seen, and most of the worst projects I've seen, mutate state all over the place. And that's what makes them so hard to debug, to troubleshoot, to fix when bugs arise, because everything is altering everything. So you have no idea to find out who altered what, who updated what, and who screwed up with. So you want to, if you need to mutate state, cool, just try to be reasonable. Try to not overdo it, okay? Great. Now, next anti-pattern is what we call the God object. This is one I'm particularly guilty of, and I think we're all guilty of when we're just starting coding. So basically, that's what we call when you start creating something that does too much. So for example, here you can see I have an object that has multiple functionalities like perform initialization, read from file, write to file, display to screen, perform calculation, validate input. Holy crap, that does a lot. That's why we call this the God object. And that is a terrible practice, because basically that makes this super hard to maintain, super hard to keep up to date. So you want to avoid these so-called God objects as much as possible. So how would you basically avoid God objects? Well, simple. Keep things modular. So as you can see here, all we did was split that God object across different more easy to understand objects like file input-output, user input-output, and logic. So basically try to avoid objects or functions that do too much. Try to keep everything as small and modular as possible to make it easy to understand, okay? Great. Now, last anti-pattern we have time for is what they call polluting the global namespace. Now, what do we mean by this? Basically, in layman's terms, creating too many globals. That's all we mean here. So this might be something you might be curious as to why we should care. Like, is it bad to create too many globals? Is it a performance concern? Is it a memory concern? And well, not at all. The main reason why we try to not create too many globals is this. Once you join a formal programming project, it's probably going to be very large. Like, for context, I work for Expedia, I think it is the world's largest travel agency. The project weighs, I think, about 10 gigabytes in size. It takes about 40 minutes on a high-speed internet connection to download. It's probably around 1 million files of code, and I have all of that on my machine. So, yeah, as you can probably imagine, there is a ridiculous amount of globals from every single developer that works at Expedia. So, when everybody's creating globals, there is an incredibly high risk of clashing on basically of you and some other random developer naming the same variable. And that is why we want to avoid creating as many globals as possible. How do we do that? Funny you ask that. We do that using what we call the namespacing technique. So basically, all we did was inject everything into one namespace variable called state, which I actually made a typo again. So basically, this is my state namespace, and everything that is related to this app lives on state. So that way, I effectively only have one global, and that allows me to pollute my global namespace even less. And this is overall a fantastic programming pattern that you want to follow. If you see yourself creating too many globals, like I think 1 or 2 globals are good, but maybe if you're going overboard, definitely consider namespacing them inside one variable to make it easier. Plus, namespacing also helps for readability purposes, because now if I need to access the score, current question, last user response, things like that, it's easier to just do state.dat, and that tells me, oh, that's part of the application state. That's easy to understand, right? And that is pretty much all we have time for regarding ANSI patterns, because we have one of the best sections probably regarding, especially capstones, which is called Easy Application Structure with Lift. Now, being able to organize an application is hard. Don't get me wrong. Like I still have problems with that. When you start something from scratch, organizing everything is not easy, you know? Like, how do I organize my files? How do I organize my folders? But thankfully, some really smart guy came up with Lift. Now, Lift is a concept originally created by AngularJS evangelist John Papa. He's one of my biggest inspirations. He's an amazing guy. And he basically created this as a way of organizing code that scales well, is modular, and makes it easier to increase developer efficiency by finding code quickly. It's overall a fantastic naming convention. This was created for Angular projects, but this is just so unbelievably good. I actually follow this no matter what type of project I'm working on. I try to follow Lift on React projects, jQuery projects, Vue.js projects, everything, you name it. So to follow Lift, you should make sure that your app is structured in a way you can locate your code very easily and quickly. You can identify the code at a glance, keep the flattest structure you can, and try to stay dry. What is dry? We'll learn soon enough. Now, these structures should follow these 4 basic guidelines, and we'll learn about each one of these soon enough. Now, guideline number 1, locating your code is easy. You should make locating your code intuitive, simple, and fast. Why? Simple. Basically, he finds this to be super important for any project, because if the team cannot find the files they need to work on quickly, they will not be able to work as efficiently as possible, and the structure needs to change. You may not know the file name or where its related files are, so putting them in the most intuitive locations and near each other saves a ton of time, and a descriptive folder structure can help with this. If this doesn't make much sense, not a problem. Let's look at some tips and tricks to keep location in check. So, tip number 1, and most important of all, is try to organize your project files by feature instead of type. And this might go a bit against what you probably learned at some online courses, and maybe in some of the examples at Thinkful. So, in some situations, we organize things by type. So, for example, for those that are already in the Node.js part of the course, this will look familiar. For those that aren't, I think this will still make sense. Basically, in Node.js, we have 2 types of components, what we call routers and models. And we basically normally try to organize them by type. So here we have routers, and inside we have the user router, post router, and models, user model, and post, again, on our typo. Oh boy. So post model. And basically, you want to try to avoid this structure and basically organize it by feature. So now, notice how we changed from routers and models to user and post functionality. So the user has the user router and the user model, while the post has the post router and post model. What that allows is that you will, most of the time, only work on one feature at a time. It's common sense. You don't want to be working on more than one feature at a time because you will go nuts. So if you're only working on one thing at a time, if you keep everything organized by feature, you only have to keep one folder open at once, and it makes it just so much easier to locate all the files for that feature. Well, if you were using this older structure, imagine you had 5 or 10 routers and 5 or 10 models. If you were working on only the user functionality, you would have to jump back and forth between these two folders. And this is made worse because you don't only have routers and models, you have a lot more type of components. So you're going to be constantly jumping between 2, 3, 4, or even 5 folders. And you want to avoid that. That's not you making location of files easy. So, summary, organize components by feature instead of type, whenever possible. Now, next tip is identify code at a glance. Now, when you look at a file, you should instantly know what it contains and represents. The why of this is because you spend less time hunting and pecking for code, and this way you become more efficient. And if this means you want longer file names, so be it. Seriously. Be descriptive with file names and keep the contents of the file to exactly one component. About files with multiple controllers, services, or a mixture, and there are deviations of the one per file rule, but when I have a set of very small features that are all related to each other, they're still easily identifiable. So basically what he's saying here is that your code should be lean, and basically within 3 to 5 seconds of somebody arriving to your file, they should know exactly what that does. And this is not easy to do. One of the biggest techniques you can do to make your code identifiable at a glance is using hoisting. As I showed you earlier, you can use hoisting to write components that basically are instantly recognizable and instantly tell you what they're doing, instead of having to read the entire file. Because that's a problem I have when I'm reviewing student capstones. I normally have to just literally skim read the entire file, which tends to be usually between the 400 to 800 lines of JavaScript code, just to understand what this student is doing when the application starts. That's not fun for me. So if they were using hoisting, I could probably just read the first maybe 50, 100 lines of code and instantly know what that file is doing when it starts. And from then on, just read the actual implementation details. Now, as far as tips, here are quite a few. So tip number 1 is always use descriptive variable of function names, even if it takes longer to write them, because funny detail for those that aren't aware, you might be thinking, I need to save myself keystrokes, or I need to write code as efficiently as possible, and that's a huge lie. In the real world, only 10 or 20% of your time is going to be writing new code, and the rest of it is going to be maintaining your own code or somebody else's code, reading over code you wrote a few maybe days, weeks, or even months ago, and wondering why you did the mess you did back then and you didn't put the effort to write code in a more readable and clean fashion. So even if it makes the code harder to write, you should always strive to make your code as readable, maintainable, and identifiable as possible. And a good example are event handler functions. Try to name them as descriptive as possible. As you can see here, these are 2 function names which immediately tell you what they're doing. This is the function that runs every time the login form submits, and this one is running every time you click on the create post button. So they're very easily identifiable just by the names. Tip number 2, always name constants using uppercase only characters. For example, state or API key, if they're constants, which means you don't want them changed or reassigned, name them only uppercase characters. This is actually a best practice amongst the JavaScript world. So when you see something with fully uppercase characters, that means it's a constant and you should never alter it. It's a good practice just to keep your code identifiable. Tip number 3, something we already reviewed, use JavaScript hoisting to write modules and components that favor context over implementation details. If you're still confused about that, this is a fantastic article called Constant Confusion Why I Still Use the JavaScript Function Statements on Medium, which I highly encourage anybody who has the time to read. And finally, we have prefer small objective functions with descriptive names which do specific tasks over hard to maintain large ones. And here you can see an example. I've seen a lot of examples and a lot of code bases when you just have one function to do everything. And that is actually pretty wrong. You should actually strive to split that up into several bits of functionality to make them easier to maintain and to fix if something goes wrong. So you can see that I have a function to do the AJAX call, HTTP get user posts. Then I have another function called convert post to HTML, because once I get the post from the database or the API, I need to convert each post to HTML. So I use this function, it receives one post and it returns HTML for that specific post. And then I have the final function to use that's called render user posts. And all that does, it receives the data from this function and it then uses convert post to HTML to convert each post into HTML, and then that injects that into the actual HTML using jQuery. So as you can see, that's far more readable, far more maintainable, and far easier to fix if something goes wrong. Or if you wanted to do this, I would actually say this might actually be a good practice if inside of this you're actually calling these three functions. If inside of this you're doing all these three functions, then this is super cool as well. I consider this a bad practice if inside of this function you do maybe 100 or 200 lines of code doing all of this functionality in one go. And that's terrible practice, okay? Good. And then we have the flat folder structure. So flat folder structure, it just says that you should try to keep a flat folder structure as long as possible. And when you get to 7 files, begin considering separation. And the reason why we say this is because nobody wants to search 7 folders, 7 levels of folders just to find one file. Think about the menus of websites. Anything deeper than 2 should take serious consideration. Like, take a look at these levels. Anything inside of this, like, it's okay, I can reach this. But they are hard to reach, like they're out of sight. And that's bad UX. In this case, many programs like this one use it because there's just so many options. They have to modularize, they have to do 2 levels. But notice how they, as far as I can see, they're only using 2 levels of folders. There is no, there is a 3rd level. But I guess this one kind of makes sense. It's very forced, but at the same time kind of intuitive. Otherwise, it would be a mess. But they do try. They do a good job of trying to keep this to a minimal of 2 levels whenever possible, just to make this easier to navigate. And basically try to keep a flat folder structure. As far as tips, I have a few ones this time. So organize project files by feature instead of type, something we already reviewed. Tip number 2, use descriptive file names on every chance you get. So for example, if you have the router, try to name it descriptively, like auth.router.js instead of just router.js. Like, I know you will figure out this is the auth router, but when you're like me and like most students working on so many files at once, you want that file name to be as descriptive as possible to tell you where you are, going back to the identify code as a glance rule. And not only that, but adding the type of the file actually makes it easier for you to maybe not need folders, because the actual file name tells what type of that is. So it actually helps you avoid the need of folders. Now, tip number 2 is avoid creating too many folder levels unless absolutely necessary. This is a bit of personal advice. A good rule of thumb for me when to create a new folder is if you have plus 15 files. John Papa mentioned 7. I like to consider 15 in some situations because otherwise you start creating folders with very few numbers of files. So take this with a grain of salt. I think plus 7 or plus 15 files are both good numbers. Okay, this is just my personal rule of thumb. And finally, we have T-dry. Basically, this just means be dry. For those unaware of what dry means, this is a fantastic word in the development world which you want to be familiar with, which basically just means don't repeat yourself. And all this says is if you're writing the same line of code or the same expression in code more than once, you should consider refactoring to basically don't repeat yourself. However, T-dry is actually very smart because it says be dry, but don't go nuts and sacrifice readability. And that is absolutely true. Being dry is important, but it is not crucial if it sacrifices the others in left, which is why he calls it T-dry. For example, he doesn't want to type session.view HTML for a view because it's kind of obviously a view, right? It's like calling dashboard-page.html or login-page.html. That's obviously a page, right? That's HTML. So here you're clearly sacrificing readability. So if it's not obvious or by convention, then basically he names it. And for context, basically you can see here a few T-Drive tips and tricks. So first is going back to it. You will be spending in the real world, you will be spending 20% of your time writing new code and 80% of it maintaining it. And there will often be times where you will have to sacrifice dry code for the sake of readability. A good example that I came up with, this is something I like to do, is complex if blocks. So I think you all stumbled across some kind of complex in blocks at some point in your career as a developer at Thinkful. Or if you haven't stumbled upon that, you will stumble upon this very soon. So here you're doing 3 checks to check if username, password, and name have values inside of them. And then if that's true, then you sign up. However, sometimes these blocks can get out of hand, and just reading through the conditions can be slightly messy, if not very easy. So we can actually refactor this to make it much easier to read. And this is what a refactor looks like. If the fields aren't empty, this should be function execution. Excuse me about that. So here we do, if the fields aren't empty, then sign up. Notice how much cleaner that looks? And then if you're interested into seeing how you check if fields are empty, you just go to the function that says fields are empty. And then you can actually verify the conditions. So all we're doing here is going back to the hoisting example. We give ourselves context. And thanks to writing functions in a readable fashion, it makes it instantly understandable what you're doing here. Like it just says fields aren't empty. That makes sense to me. And I think it makes sense to you. So it makes us be able to understand this at a glance instead of having to understand the logic behind it. And then if we are interested in understanding the logic, like maybe we need to fix a bug or something, we just command click on that. If you are using something like VS Code or Sublime, you can usually do command click on Mac or control click on it, and it takes you to the function definition. And that is why hoisting is such a great feature. You can just write your code so much cleaner, as you can see here. And that would be pretty much it. That was a very cool session. I hope you guys enjoyed it. We have 5 minutes for questions, which is shorter than I'd like, but I'd love to hear what you guys think of it. For those that enjoyed the presentation, I will be sending all of you... crap, I can't text it. I will be sending you a quick feedback form where you can download the slides for basically these slides. You can download them and just view them on your own personal time. So let me just quickly send you this feedback form. When you answer that, you will be getting a link to the slides. So don't close that form. And the feedback form is literally 4 questions rated from 1 to 10. So it shouldn't take you very long to answer them, to be honest. I try to keep it clean because, you know, I value time as well, guys. So let me quickly send you that. Oh, and let me stop the recording. I think that's about it. Now, let me verify it did generate the PDF correctly with the fixes we performed over the session. No problem, Nicholas. Yeah, I imagined it would be nice if you guys had the notes, to be honest. Okay, there we go. I'm uploading the doc. Okay, here is the feedback form. So here's the link. Okay, here is the feedback form. Oh, wow, I'm just reading your comments. Wow, that is so nice of you, Nicholas and Chelsea. Thank you so much. I really value that. I put a lot of effort behind these, so it makes me really happy that you guys are really enjoying these. But still, if you have any feedback, negative feedback. If you have any negative feedback, like something you don't like, please go for it. I'd love to hear anything you feel I could improve on these, because, you know, I might think I'd be doing great, but I'd love to do even greater. I love to improve, because success is all fine, nice, very cool to feel, but failure is what teaches you. Failure is what makes you improve, and I'm always on the lookout to improve. So anything you feel I could have done better, or maybe at the last you can even suggest some workshops you'd like me to do. If there's a topic you'd like me to cover, feel free to suggest it. If there's something you really enjoyed and feel I should keep doing, feel free to list it, one of the last questions. And thank you all for attending. I really appreciate the big audience we had today. Don't forget, I will be uploading as soon as this uploads to YouTube, I will be sharing a link to it, to the recording on my personal YouTube channel. And thank you. Again, I can't thank you all enough. So, does anybody have a question? It could be related to the presentation, maybe non-related, could be a personal question. Absolutely anything, seriously.
I have a question.
Sure. What's up, Davey?
So to be clear, do you prefer the arrow function or the function keyword itself?
Neither.
Because the arrow. Say again.
Neither. I actually can't prefer either. Like, you have to use the right one for the right job. Like, for example, let me give you a super easy example. If I'm writing a function that only returns one line of code and it's a simple one-liner, I will always use an arrow function. Simple reason, it's cleaner. It's much, much cleaner. But if it's doing more than one line of code, or if it's maybe if it's too extensive, I will normally want to use the function keyword because it's just maybe not more readable, but I can name functions, and naming functions is important to me because when there's an error thrown, you normally get a very nasty looking call stack. When you use arrow functions, the error looks like an error happened at the anonymous function. Yeah, that's not very helpful to me. I would like to see errors that say an error happened at render nodes function, or an error happened at get nodes function. And when you use arrow functions, you can't do that.
So does that still apply even when you want to hoist?
You can't hoist arrow functions. So
right,
if you want hoisting, you cannot use arrow functions. That's also another case where you wouldn't use arrow functions.
Okay, so because I've seen articles that say, use or don't do function declarations or use function expressions. And
wow, that is a super smart comment, David. Thank you for making that. And I think everybody in the class should pay very close attention to what I'm about to say, because you actually mentioned a very controversial topic without realizing. There's a lot of internal debate between developers that prefer function declarations that prefer function expressions over arrow functions. So for example, there's a lot of developers that swear and live by only doing this. They never do function declarations. They only do function expressions like this. The reason why they do it this way, yeah.
So in that example that you're highlighting, you cannot hoist that because that's an assignment.
Yes. So there's a lot of developers that only like to do this type of declarations. And I made quite a lot of them. The reason why they justify this is because they feel hoisting is bad, because they feel it's maybe hidden functionality of the JavaScript engine, that it's maybe shaky, it's unreliable, you shouldn't rely on it because it's hacky. I've heard all kinds of arguments. So let me tell you mine. I use hoisting because it helps me write much more cleaner code. It helps me write code that works like my brain. It gives me context. It tells me what I'm doing, and only once I have the context, I can actually write the implementation details. And it's not hacky. Like, hoisting is well-documented JavaScript behavior. If you Google hoisting, there's a ridiculous amount of articles, even official sources like Mozilla Developer Docs that basically explain hoisting. So yes, there is a lot of internal debate between developers if hoisting is good or bad. And I think you will find developers just equally split. I advocate strongly for hoisting because I think you already saw my point. Like, it's well-documented. It makes for much cleaner code, so why you shouldn't be using? And even John Papa advocates for it. He's a strong, huge authority in the Angular community. So I guess that's my opinion. And as all opinions goes, they can differ. So I think hoisting is cool. If you don't like it, that's cool too. We all have opinions, but that's my 2 cents on the matter.
So for example, I notice when I write code and it's in the global scope, I'll use the function keyword. But let's say I'm like using React and I'm passing functions to components. I'll use the arrow just because it's like a lot cleaner to write. I don't know. I'm just comparing code examples.
Sure. No, that's good. That's okay. As long as you don't rely on hoisting, that's okay to use arrow functions. However, I do have to mention, excuse me for the students that haven't reached the React phase, React components work very differently because I'm pretty sure the functions you're defining in React are what we call class methods. That's a bit of a more advanced topic. And for class methods, there is no hoisting. The classes work very differently. So in classes, you could make an exception to use this cleaner syntax because there's no benefit to using function declarations here.
Well, no, I'm talking about like, or let's say when you use a promise, like a bunch of thens, I'll write what's passed to the then as a arrow function.
Oh, that's a perfect use case. I love to use arrow functions for then callbacks. They're just so much cleaner, right?
Yeah.
But overall, great comment. Seriously, I love that you asked that. It was great. So other students could learn about probably the internal debate, because especially I linked an article on this slide, the one that said about this one, identify. This article is an absolute godsend. I read this article so many times. It's just a must. I have this bookmarked in my All Stars favorites tab, because this just explains almost a good chunk of what I just covered on how function declarations and hoisting can basically make you write functions in the way that your brain understands it. Because seriously, this is just an absolute boss of a phrase. The ratio of time spent reading versus writing is well over 10-1. We're constantly reading old code as part of the effort to write new code. Because the ratio is so high, we want the reading of code to be easy, even if it makes writing harder. And he's absolutely correct. So this person goes into a lot of detail into why he uses hoisting and why he prefers to keep using function declarations and hoisting over expressions to keep his code cleaner. So it's an absolute must read as far as hoisting goes. So be sure to check that out. It's in the slides, by the way, for anybody who answered the feedback form. And I'm a bit over time, but I think let's do one more question. Does anybody else have something they'd like to ask before I leave the room? Nobody?
Hello.
Oh, hello, Shirvani.
Hi, I just got one doubt regarding arrow functions. I just read somewhere that like if you get any error, it won't indicate the line number as such. Is it?
No, that's not true at all. It depends on how you're running the function. If that happened to you, then an arrow function would have nothing to do with that. An arrow function should also give you an error. What arrow functions do cause, which is something I do not like about them at all, is that when an error happens, the error just says an error happened at the anonymous function. And that's absolutely not helpful at all. So, yeah.
It's the problem. Yes. Okay.
Well, I guess no more questions. Thank you, everybody, so much for attending. I'm glad that some of you, I think from the claps, I guess everybody enjoyed the session. That makes me very happy. I sadly haven't had the chance to do the part 3 of the full stack capstone workshop, which I gave last week, which I know a lot of you were looking forward to. I tried to submit a request to give that workshop, but it hasn't been approved. So I will probably do that next week, how to build a front end for a Node.js full stack application. And as far as in upcoming workshops, well, stay tuned. I will probably re-give some of my previous workshops and work on new ones because I'm actually quite enjoying this, especially for topics which I feel we could be doing better as an organization at Thinkful. Just to cover, because you guys should always be getting an edge. Like there's, unlike people like to claim, like, yeah, there's so many developer jobs, we can fill them. That's so not true. I learned that harsh truth when I first became a developer. Like there is not enough developers to fill in developer jobs, but that's actually for the high-end jobs, like the highly specialized jobs, like the ones that require a JavaScript expert or a Node expert. Like we have that problem in my company right now. We are actually right now hiring what is a full stack developer with basic Java knowledge, but he has to be an absolute expert in front end. And we honestly haven't been able to, we have a lot of people who know Java and front end, but we haven't found anybody who knows enough about front end to pass that interview. So basically, if you want to succeed, you really want to push yourself beyond above the average number of candidates. Like I know this will sound harsh, but there is a surplus for mediocrity. And I do believe Thinkful is doing an absolute fantastic job at preparing really above and beyond candidates that go beyond the usual very, excuse the word, lousy average quality of boot camps. Thinkful just is doing a fantastic job, and just doing more workshops on topics that Thinkful doesn't cover is probably the right approach to give you guys enough information so you can nail your first coding interview. So glad you guys enjoyed it. And thank you so much for the kind comments. That really helps me keep doing this because it's nice. It wouldn't be very nice if I kept doing this and just got negative comments. So thanks everybody. I hope I will be seeing some of you soon at some of my other workshops. And take care. Have a nice rest of your evening. Bye bye.